Great, hello. This is the demo section of this presentation. I'll be showing you how you would go about checking your system to see if it's KVM eligible, how you would go about downloading the KVM modules, and some of the system management you will need for making your VMs. So the first thing you're going to want to do when you get on your Linux system is you're going to want to see if you can even run a KVM machine on there. To check this, there's a command grep, and you're going to check the proc CPU info file to determine which kind of CPU you are running. In this case, we are running an AMD processor. The next command you're going to want to use will determine if your chipset, the specific chip, supports virtualization. So for AMD processors, this is called SVM. If you are running Intel, it is VMX. So we're going to grep for SVM. As you can see, we have SVM in our system. Another way you could check this is by checking the modules. So you can see we have KVM AMD here, KVM. So once we know that the system can run VMS or KVM VMs, we're going to actually want to install all of the different KVM utilities and packages. So in this case, they are the ones listed on the slides. We have the QEMU KVM, the libvirt, virt install, virt viewer, and virt manager. I already went ahead and installed, so that was quick. After you install, you can verify even further that your host's machine is ready for KVM virtualization by running this virt host validate command. There may be a few warnings, but as long as there are none that fail, you can run it. So some common ones, you may have the secure guest support not supported with the warning. That one is hardware specific. IOMMU, you will need to enable that in the BIOS for pass-through. And the C group, your system may be running C group 2 for devices, in which case it will just present as a warning. The next step would be to start up the libvirt daemon. So you can do that with systemctl start and libvirtd. Then you can enable it so that it is started up on system boot. And you can then verify that it is enabled and started by doing systemctl status libvirtd. You can see we are active and running. So that means that we are ready for KVM installation. Before we get going there, you may have to add the user to the libvirt group. In this case, it is a simple user mod -ag libvirt is the name of the group, and then your user. So my user is OPC. And we can see that we are added to this 990 libvirt group. I am running this on the MOBA Xterm terminal emulator, which has X11 forwarding, which will come in handy for our next section, which will be a quick tour of the Vert Manager. Okay, here we are. So one thing that you can do is select the QEMU KVM. This is the host. And the first thing I like to do when I start on a fresh machine is go to Edit, Preferences. And you can check this off to enable XML editing. This will come in handy in the future. If you're ever adjusting your VM configuration and you just need to make a quick adjustment and you're familiar with XML editing. Another thing, you can adjust the defaults for your graphics, storage, x86 firmware. So if you're only running VMS, it may come in handy to change this over to the UEFI. I will just refrain from doing that for now, but it is a handy tool and you can utilize that. The first process that we're going to show is how you would go about creating a storage pool. So this is where libvirt is able to access your virtual disks that you create for the VMs. So you can do this either in the VM creation when you're creating the actual VM, or if you go to Edit and Connection Details here, and you can hit Storage. And this is the screen for the storage. On the left side here in this column is where the storage pools will be. And when you click into them, they will have all the volumes that are associated with it. libvirt itself creates a default directory in var lib libvirt images. I will go about creating a new storage pool just to show the process there from the GUI. So you click on this bottom left corner with the plus sign. And after a little bit, it will show this screen. So as you can see, there are a whole bunch of different types of storage pools you can create from. In this case, for the demo, we will just be using a dir file system directory as it is the simplest to make. So I'm going to actually make a little subdirectory here. Just gonna call it VM. And I'll name the pool VM. You could also click browse and browse your whole file system if you'd like to determine where you should store your files. For simplicity's sake, it may be easier to use this directory. And then you click finish. And you can see our new storage pool was created right over here. It has the location and it will specify the size of the available gigabytes. To create a virtual disk, a QCOW2 virtual disk from this screen, you'll select the storage pool you want it to be associated with and hit the plus next to this volume. And it will bring up this screen. You're going to want to give your storage device or QCOW2 file a name. In this case, I'll just call it test. Format, we're going to leave it at QCOW2, but there is also a raw, I believe. Yep. I'm going to leave backing store as it is, and for the volume, I'm going to give it a 15 gigabyte. And you're going to want to check this allocate entire volume now. This will ensure that the disk is thick provisioned, which is the VMS supported disk provisioning. And once you have all these fields set, you're going to want to hit finish. I'll just show what the XML would look like for this. So you can see it has the volume as the object, the name, capacity, allocation, format. Hit finish. And it will show up here in just a minute. So now we will actually go about building the VM. So you will select the host and hit this computer with a star on it. As you hover over it, it says create a new virtual machine. Okay, we will select the local install media, hit forward, and we're going to hit browse to locate where the file is. I have it in a different directory, so I'll just make a quick pool for it. If you don't want to make a pool for it, you can also browse local here. It didn't work. Right, I will browse local actually. There it is. So you can see we have it selected here. And VMS is not in the list of the automatically detected installation medias. So we're going to want to uncheck this box here. And in this field, we're going to type generic and select this generic or unknown OS. And we click forward. Okay, so now we are at the point where we're going to configure the RAM and CPUs for this machine. VMS can go lower than 8, but it's not recommended. So I will do 8 gigabytes and have 2 CPUs. Now at this screen, you can either create a disk image. If you use this option, it'll create it in the default location, which is that var libvirt images directory I was talking about. In our case, we are going to navigate to the QCOW that we created and use that. So we're going to select or create custom storage and then click manage. And then we had it in this VM directory. We do select and choose volume. And hit forward. This will be the name of the VM from the libvirt QEMU perspective. So it will show up in here once it's created. So we can see we have the generic or unknown OS type, local CD-ROM ISO, 8 gigs of RAM, 2 CPUs, and the storage will be at this var lib libvirt images VM test key QAT2. Before we hit finish, we need to make a few adjustments. So I'll click this checkbox here to customize configuration, and then hit install. So we are brought to this screen, and the first thing you're going to want to do is change chipset over here from the i440FX to Q35. And the firmware, we're going to want to change from BIOS to the UEFI. The title and description are optional. They won't really impact anything on the VM, but it will be helpful for if you have multiple guests on the same host. So you may want to be a little descriptive here. So this, I'll give it a title, Bootcamp Demo, and description. This is a machine for the Bootcamp demo. Once you have all these done, you're going to hit apply to save. Okay. The next step is we're going to want to change the disk bus from IDE to, in this case, I'll do SCSI. This disk is going to be our system disk with the test QCOW2. You're going to want to hit drop down here and make it so that the cache is right through. You can hit apply. And the same thing here, we're going to want to change the ID CD-ROM2 to, we'll make it a SATA. And hit apply. Here is our NIC. So it is currently attached to the default libvirt vir BR0, which is a NAT bridge. We will leave it at this, but we can change this to E1000E or virt.io if we'd like. We'll hit apply. And then if you'd like to add other NICs, you could hit the add hardware button in this corner and go down to the network, and then you would add it here. You will need to add the controllers for these two disks. So we have the SCSI one right here with type SCSI, model virt.io SCSI. Okay. And once we have all that finished, we can hit begin installation. I didn't connect to graphical console. Okay. We don't need that anymore. Or maybe it's just slow. I'll exit out of here just for a second. You can see the machine is running over here with the CPU usage. I'll exit out to get back to this. And we will use some of the versh commands that we'll cover in a minute. So to access the console, we're going to want to use this versh console command and with the name of the VM. So as you can see, we have the boot manager and we have the CD drive, CD-ROM for the ISO. So once you have this screen, it would just be normal VMS booting. So we can do that right here. And you can see we are going to slowly install the installation kit. So it is going to take a while to do that. I don't want to wait for it. So another versh command that comes in handy is the versh destroy. This is the equivalent of a force off. So I'll just hit this real quick. And you can see it is destroyed. To list only active VMs, we'll use versh list here, which of course will not be helpful as we just destroyed it, but you can view all of the VMs using the -- all qualifier. So you can see test is shut off. And from here, I will go back to the virt manager and we will delete this test so that we can go through all of the virt install and versh commands through the command line. So to delete a VM from the virt manager, it's really simple. You just select the Bootcamp demo and hit delete. And you will have the option if you would like to delete the associated storage. In this case, we will. So we hit delete. I'll ask for confirmation, of course. So now we got rid of that VM. And we can see over here, the VM is no longer in the list of VMs, even the ones that are disabled. So that is KVM with the GUI. So as mentioned earlier, there is a command called virt install, which will provision new virtual machines. There are a whole bunch of options. So I will show how you would go about making a very simple bare bone VMS machine. Before we do that, we'll create the QCOW2 as we did before. So let's see. Oh yes, I forgot one thing. We will make the storage pool first. So to make it simple, I'm just gonna switch to root because we're gonna want to use root for most of these commands now. You can view pools, storage pools, by doing verse pool list. Do all. As you can see, the ones that we made in Vert Manager are all present here. To create your own, I did not mean to do that. So if we wanted to make our own storage pool, we would first make a directory. I'll just call this dir. You can see we have it over here. I don't need to do sudo anymore. To create the pool, we're going to first define it with pool define as. Then we're going to want to specify a name. So I'll call it dir pool. Specify the type of storage pool. So in this case, we're using a directory. And to create the target, we're going to specify this path. Double hit enter, and you can see the pool, dir pool is defined. Then we will want to initialize the pool with the pool build command. You're going to want to use verse pool build and the name of the pool. So we can see pool is built. And at this point, we can check the pool list and we see dir pool is in the list. It is inactive and it is not set to auto start. Again, auto start would be when the host system boots up, this storage pool also boot up. So you don't have to manually start it up every time. So to start the pool, use the pool start command with the pool name. And to set it to auto start, the command is pool auto start and the pool name. So we can confirm this again using the pool list. You can see it's active and set to auto start. And another command that you can use is pool info, just to get more information about the pool. So we can see the capacity, available storage, and a few other useful information. So to create a volume in this pool, we're going to use this QEMU image create command. So QEMU image space create. And we're going to want to specify -f for the type. in which case we'll use QCOW2. -O to add an option, we will add the option of pre-allocation and set the value to full. This will thick provision our disk. And then we're going to want to specify the name of this. In this case, or before I do that, I should probably go to this directory. So we'll just call this one test.qcow2. And then we're going to want to specify the gigabytes. In this case, just 15G would be 15 gigabytes. So this will take a little bit because it is allocating this whole 15 gigabytes on the virtual disk. And now that we have that done, we can check using fo, I believe. Yes. So this will have information on the QCOW2 that we just created. So you can see the size, cluster size, format, specific information, and yes. From here, we are about ready to make our VM. So as mentioned, there was a very large command that we will need to run. I put it in, yes, okay. I just have a little sample one here. So here we'll specify the name, the description, similar to how we would in the Vert Manager. Then you will need to specify the RAM and vCPUs. CPU equals host. This one is important to specify if, well, it will, I shall consult the man pages. Here it is. Expose the CPU's configuration to the guest. Okay. And then we can see here we have two disks. This first one is the CD-ROM, which points to our ISO file. I made it also be a SATA type on the SATA bus. I gave it boot order 1, and I made it shareable. And the second disk, it points to, this was a test I made, but it would point to the directory where the QCOW2 is stored. That specifies as a size, so we'd use the same size that we configured it with. Give it the SCSI bus, and for cache, we're going to use write through. That is the supported KVM or VMS cache write through. Ugh. And setting sparse equals to no will fully provision it. The next section here, the network, we'll use the default libvirt bridge, and we'll create it with a model type E1000E. At this point in the live demo, there was a question about this graphics equals none. If you plan on using graphics for your VMS guest, or if you also wanted to use the guest console, you wouldn't want to specify this as none. I will go back to the man page. There are a few options for this. So you can use VNC, Spice, none, which is what I prefer to use. So there are a few options you can enable depending on your needs. If you don't plan on using graphics in your VMS guest or use the guest console, it may be better to just disable it. This will boot the VM into the terminal. Well, this will, but it won't allow any graphics, and it will just remove any overhead there. This --OS variant, this would be similar to the auto detect in the Virt manager, where VMS is not in that list, so we would have to specify that we do not have a pre-configured OS. This machine is the chipset, and we will use Q35 as that is essential with using UEFI. This bootloader command here, or option, it configures the UEFI firmware. For serial, we used the PTY, which will create a pseudo terminal. You can also, if you wanted, assign a serial port that you could telnet for console access. But to keep it simple, we will just be using the PTY. So if we go ahead and copy all this and paste it, I will just make the change over here. So we have the correct path there. Just hit enter. And we can see, depending on the version you use, this model host may be deprecated. They'll give some suggestions. These are all just warnings. This OS info as well. You can see it started the install, created the domain, and the domain is not running because we did not specify to boot on completion of this. There may be some more errors, but you will see it gives you this command here. So if we just copy that, it will start the VM. You could also start with a simple verse start. And if we go to the console, you can see we are here with the boot manager. And that concludes the demo section of this presentation. All right, thank you.